All right, here's your application. Here we go. Solve. First two kind of similar to what we did in this actual lesson here. So I'm not going to go through much here on these first two, but what I'm going to do is make sure you find the LCD here, or the LCM. I'll go LCM, doesn't matter. And if it's 2, 7, and 2, remember this is really a 1, so that's 14. So I'm going to multiply everything by 14. Okay, and then cancel and then figure out everything else. This one here, I want to solve. This is what we call a compound inequality. Remember, we talked about that up in our actual lesson, inequality. Okay, and I want to move the 4 over to this side and over to here, right? And I want to get rid of the 2 as well, okay, to both sides there. And there we go. Again, the answers will be on the packet for questions 1 and 2 and anything else on the application video. All right, being since you took geometry last year, or you at least maybe are taking it this year or not, you have to know a little bit about maybe some geometry stuff. And you're like, well, this is algebra 2. Well, you're right, but still, we can still do some geometry stuff. So again, Sully took a class field trip that included the ice skating, lunch at Yabadoo's, and then the German Ballet Theater. The class is going ice skating first, then will proceed 85 kilometers to Yabadoo's for lunch. Finally, they will drive 75 kilometers back to Yabadoo's for the German Ballet Theater before finally returning back to the ice skating rink. Okay, so again, we need to understand, just because you have a paragraph there and there's a lot of information there, that really is important. So ice skating is kind of important right there. 85 kilometers is important. The place called Yabadoo's is. 75 kilometers is important, right? And then the German Ballet Theater as well. And then we're going back. So part A basically says I want to have a triangle inequality theorem. Remember, it states the sum that the lengths of any two sides of a triangle is greater than the length of the third side. What that means is, if you take two sides of a triangle, you add them up, it should give you longer than the third side. It has to, otherwise they don't actually touch and it wouldn't be considered a triangle. So I want to make a triangle with all of these things here. So if I have the ice skating rink, okay, here's the ice skating rink, and then we'll say this is Yabadoo's. Yabba Dabba Doo! Right, from, what is that from? I don't know what that's from. I forget. If you remember, just tell me in the class, please, because I'm going to forget, and I'm not going to go look it up. So I went from, where did I go? I went from the ice skating rink to Yabadoo's. So I went from ice skating rink to Yabadoo's, and that we know is 85. Then I went from Yabadoo's to the German Ballet, which is down here, and that's 75. And then what happened was I went from the German Ballet Theater back to the ice skating rink. And I do not know this value, and that's x. Okay, so what I want to do is I want to write a compound inequality. What that means is I want something to be less than x to be less than something else. Okay, well, what's the highest number that is going to be here, okay, for these two lengths of a triangle? Well, x can't be bigger than these two numbers added together. 85 plus 75. If I add those together, okay, it has to be bigger than the x value. So that means x can't be anything bigger than, what is this? If I actually do, that's 160, right? X can't be bigger than 160, because otherwise the triangle inequality theorem would not work. Then, what do you know about this number here? This number has to be x plus 75 has to be bigger than 85, right? And then x plus 85 has to be bigger than 75. So there's a little hint there. I'm not going to tell you the answer. Again, it'll be in the packet, but I'm not going to do that here. This number has to be, if I add them up to both sets of 8 numbers here, they have to make it so that they add to the bigger than the other number. All right, that's really pretty simple there. All right, so Sully said the distance of the German Ballet Theater to the ice skating rink is 170 kilometers, but Brust knows that it's not correct. Show the calculations Brust would use to prove Sully wrong. Well, if I know that my triangle inequality theorem and like my compound inequality here is some number, right? We got to find this number from here. This number is going to be the same, is less than x, which is less than 160. Okay, this means that this distance here, it has to be less than 160. Well, this is 170, so we know that this cannot work. So cannot work because it must be less than 160, and it's already greater than 160, okay? So we know that that is false. But again, you have to find this number right there. Oh, right. Between Frankfurt, Germany and Kaiserslautern, Germany, there is a portion of the Autobahn that has no restricted speed limit. This Autobahn, if you guys do not know, it's a highway in Germany that there are parts of it that there is literally no speed limit. Okay, you could go as fast as you could possibly go. Now, again, don't kill yourself or anything when you're going, 3,000 miles an hour, but you got to go within reason. But as fast as you can go, you can literally, there's no speed limit. But it does have a minimum speed limit of 80 kilometers per hour. 80 kilometers per hour, I believe, is right around 50 miles an hour. So this is, again, right around 50, which I was close. I was just guessing, but, man, I checked that in my calculator, and it was pretty good. It's about 49.7. All right, so what that means is you can go 50 miles an hour or 210 miles an hour if your car will handle it. Okay, you can't be driving, a little Ford Escort or a Volkswagen Beetle that fast, but maybe, you got Lamborghinis or whatever that'll go that fast. All right, part A, write inequality that describes the speed S of a vehicle on the Autobahn with no speed restriction. So this speed of a vehicle, we know it has to be greater than or equal to 80 kilometers an hour. Okay, so that was a pretty simple one. That is the posted speed limit basically on that section there. You can go 80 or higher. All right, between Baumholder and Ramstein, the speed limit of 130 is posted and the minimum speed drops to 60 kilometers an hour. Write a compound inequality that describes the speed S of a vehicle on that section of the Autobahn. Again, remember, a compound inequality needs to be like something like this. Something is less than X, which is less than something else. In this case, you can go 130 kilometers an hour, and you can go 60 miles an hour, or 60 kilometers an hour. And I know because we're in, America and we don't really know what kilometers per hour is, but this is roughly 80 miles an hour, and this is roughly like 37 miles an hour. Okay, so you can go in between those speeds. So because you can actually hit this value and hit this value, you're going to need less than or equal to on those. So again, I'm not going to tell you what the answers are, so plug in a number there, plug in a number there. Pretty simple there. All right, that concludes your application there in point 2. All right, getting you wrapped up for the beginning parts of Algebra 2 here.